So, as we look at this information, we try to color code that just a little bit for with that of in the right column are the acids that we would like you to know. And I think students get so caught up or hung up on these acids and just don't just stop to think for just a moment. This is not that bad. But I know you would be saying this and you'd be right. Say, well, you've been doing this or are familiar with these because you've worked with them for 15 years. And I really don't have an argument on that either. But just a way that you could rationalize that is if one of you was trying to describe where it is that you live, you know, some people can do that quite well given directions. You probably, you might not be able to because you just go there. You really don't pay attention to taking a left on 234th Avenue up to 474th Street or whatever. Now that's country directions as opposed to that of living here in town, because they'd have specific names like Krumer Avenue or 3rd Street or something to that effect. But regardless, the reason I say that is when we go to balancing out these compounds, we said always go by which ion. The positive or the negative? The negative ion. Okay? So when we do that, okay, we'll just start from the bottom and work up. PO4, that has a charge of negative what? Negative 3. So the reason that that's significant, I should see if I got a different color in here. I've used neon green before, but I don't think I want to do that. Well, we can try it. Because I don't know if, well, we could try orange, but that kind of clashes with the red. Let's see if that shows up. So if we know this is a negative 3, can you see that? Okay. So then, from prior knowledge, what's the charge of hydrogen? Even if you just looked at Bob over there from a distance, I would expect that you would know what charge hydrogen is because of the location that it is on the periodic table. It's positive 1. Why? Okay, you're close. It's in the first column. So you put the bit of information that you had, it has one outer energy level electron. That's true because it's in the first column. So those two mean the same thing. It's just a different way of describing it. So that means that hydrogen has a charge of +1, which it does. Okay. So +1 times 3 gives you what? Positive 3. So positive, how many phosphate ions do we have? Just 1. So positive 3 plus a negative 3 adds up to what? 0. And that's what you want to do to write out these compounds. The charges have to add up to 0. Okay? So why do you suppose this is called why do you suppose it gets its name, phosphoric acid? What element is in phosphoric acid? The phosphate, mainly phosphorus. That's kind of the same. It's kind of like what you students were saying, column 1 and 1 outer energy level electron, meaning the same thing. So the reason it's phosphoric acid is because it has the phosphate ion, and it's got phosphorus in it. So if we did not go any further in naming this, what acid do you think this is, because we've got that element in there? You're fairly close. Okay, so since it has nitrogen, it is nitric acid. Okay, so there again, what's the charge of this nitrate ion? Negative what? Negative 1. It's right here. And we already established this is plus 1. Plus 1 and minus 1 adds up to 0. Okay? So, do we remember what SO4 is? Sulfate, and it's sulfuric acid. Okay? All right. So now, what do you suppose the charge of the sulfate ion is? Negative 2. Okay? Well, it's also right there. Okay? So then, again, plus 1. Plus 1 times 2 gives you plus a negative 2 equals 0. I'm actually writing, are they neutral as far as the charges are? Yes. All right. Then probably these two would be the most two common acids that you're probably familiar with. So what do you suppose this top one is? It's hydrochloric acid. Okay? Hydrochloric. Okay? So chlorine has a charge of negative and plus 1. Those two add up to 0, just like this one. So notice that when you had a charge of negative 1 for these two, you only had one hydrogen. Because plus 1, negative 1 adds up to 0. I don't know, it'd be unfair for me to say, well, that's simple. Well, yeah, it's going back to, well, I've been doing this for a little bit longer than yourselves. So at some point, one of the things that we've done in the past, more so with the organic chem class, is if you really understand this, maybe have you people come up here and you stand on this side of the desk and you explain it to your classmates. Do you like that idea or no? How boring is it you listen to the same person every day? But one of the things that I try not to do, I don't know how good we are at it in here, is throughout the course of discussing something, is trying to change the pitch or the tone rather than just saying, okay, so we've got hydrochloric acid, sulfuric acid, nitric acid, and phosphoric acid. You're going to want to copy down NH4 plus 1. What does that sound like to you? What's that called? Monotone. Would that be awful or what? So we try to change the tone, the pitch, and the emphasis. That I think just sitting here and saying this in that monotone voice, that would be awful. Okay? So now, when we look at these four should not be too bad as far as naming what the polyatomic ions are. Okay? So you got a funny look on your face thinking, oh, don't ask me. Okay, yes, what? Oh, I thought you were saying question. Okay, we'll start from the left side and work to the right. So, Grace, you get to pick one of these four. You name one of these. You tell me which one. That's called what? Well, that would be if it had a phosphate. This is the phosphate ion. Okay. Next, working to your right, okay, go ahead and pick one of the three. Sulfate, that's right. Okay. Next, which is what? It's a nitrate. Okay. Then finally, what do we got? What's this one? Carbonate. That's right. So one of the things I want you to note is we've already jumped into, we could say, the deep end of the pool. Okay. How do you remember this from physical science? So how is this, the content is not any different than what you learned in physical science. But what we've learned the last 10 minutes, how's that different from what we learned 2 years ago? Well, it's, what about the speed? Say we're going through it a lot faster, okay? Because, okay, in 2 years from now, maybe down in Vermilion, up in Brookings or Sioux Falls or out in Rapid City or wherever it is that you're maybe going to a post-secondary learning institution. Okay? So, this is maybe a, so since you're thinking of going to Harvard, you should be able to come within probably about 50 years of this, I hope. When do you think Harvard was founded? No, way too late.
You gotta give him props to the confidence level he had. One time was 18. He was ready to get it.
Okay.
17. No.
No, I want to say it was probably 14. In the early 1700s, maybe the late 1600s. Probably 1690s or so. Yeah. But one of the things, it's funny, the History Channel used to have this segment, how the states got their shapes. I don't know if you've ever heard or seen that show, and it's actually pretty interesting. Well, we're more so of a box out here. Reason I say that is notice on the north and south parts of our state, it's just a straight line. So is the west side. So, and a lot of the east side of the state is a straight line as well. But why do we got the zigzag line in the lower right-hand corner of the state? It's because of what landmark? Well, not landmark, but what part of the geography makes it that border? It does, but a little more specific. You had the right letter, but the wrong side. Missouri River. That's right. Right. Okay. Water. Yeah. But you had the right idea. Okay. So, the main idea that you need to accomplish with these is get the charges to add up to 0. We went through almost all of these. Do you remember what OH is? High something. Ox. Hydroxide. Because some of you, I got to look for something specific. So, Shannon, yes. Jordan, no. Grace, yes. No. Earrings. So, okay. So, what might, I know, that's why I said we'll leave you out. What do you suppose earrings has to do with something with OH? It's clear. What's the disinfectant? It's not hydroxide. No.
Wait, hydrogen. I don't know. What does it start with?
H.
Hydrogen.
You're right. Hydrogen what?
Hydrogen chloride.
Hydrogen peroxide. Okay? No. Well, let me, yeah, the properties are totally different. The reason we say that, okay, when you're talking about alcohols, for those of you who go on to take organic chemistry, maybe yes, maybe no, this, for instance, is probably one very important organic reaction. Okay? The reason I say that is for those of you who do take this class, we say it's all about the water when it comes to that of organic chemistry because there's so many reactions that take place that water is involved, whether it's something that's added, something that's removed, or in this case, when we break this apart, when you say water, really it's +1 and -1 in that effect, because remember hydroxide is -1, because what we see happening here is in this reaction, we see this compound form. So it's kind of related to the question that you were asking. Are they related? Well, yes and no, because when you get a flu shot, this might be what? This is isopropyl alcohol. It's a very common disinfectant. So okay. So when we use this is probably a very common reaction. Okay. Are you writing this down? I mean, that's fine that you are. We're not going to be utilizing organic reactions in general chemistry class. I mean, it's great that you... Okay. In the spring it is. Okay. So does everyone have this information that wants it? Okay. Okay, now, what is NH4? Do we remember by chance? Either that or open up to chapter 7 and see if you can find it. I believe it's chapter 7. In specifically, it would be... It's ammonium. That's right. So what you're looking for is a table that has all of these ions on here. Okay? Notice on page 226, it's got the polyatomic ions. How is that different than the table that you see on page 221? So compare 221 to 226. You said it right, but you said it backwards.
Polyatomic is more than one. Monoatomic is more or less than one. One.
Okay, that's correct. Okay, so you had identified this as ammonium, so that's right, ammonium. It's not the only positive polyatomic ion, but it's the only one that you're responsible for. And then finally, we had already said that OH is what? Hydroxide. Okay. So, one of the things that we want to do, maybe you don't, but I want you to, is we're going to start utilizing a lot of this information. And let's say you had to, not that. Okay. So for instance, now, a lot of people like to ask when they transfer in, or maybe they had physical science before, like say, do you make them memorize the periodic table? No. Why would we not want you to memorize that? Well, that's true. Chances are. after you learn it, you leave these doors, you're probably not going to remember that. When we look at that, we want you to know how to use it, not memorize it. Because if you know how to use it, you're always going to have that opportunity to learn more information. Same thing when it comes to the organic reactions, okay? Rather than memorizing all of those reactions. All of these reactions in the different stages. These reactions and these reactions. 4 pages of reactions they are responsible for. Would that be terrible to memorize all of them? So, well, the time isn't the problem. It's just that more and more information gets added on in sometimes quite quickly, sometimes not, a little more time. And how do you keep separate which ones have 2 stages, which ones only have 1? Which one goes one direction because of one temperature range as opposed to a different temperature range? A lot of those factors then are given to you as a tool on these organic flow charts. Okay. So speaking of as a tool, who can I pick on in here?
Cole.
So if you ever thought, Cole, don't be a tool. You ever heard that before? But a tool is something that helps you accomplish a job. So really that should be a compliment.
No.
Right?
No, a tool is like. No, let me educate you. A tool. A tool is like where you're a jerk and you just think that you're all that. No, I think a tool. Yes, it is. No, I think a tool is like. A tool is where you're not intelligent.
Actually, I know, right? Yeah.
Yeah, smart out. Anything you know.
So technically, yeah, this is a scissors, but this is a tool. It helps you accomplish a job. So I get it, it's slang term, I know, but whoever thought of that, I thought is kind of strange. Don't be a tool. A tool is helping you, not hindering you. But why is it Cole all the time? Because he
doesn't get offended by this.
Okay, fair enough. Okay, so when you see the name, you need to write out the formula. So the formula for calcium chloride, the symbol for calcium is what? Okay, now chlorine. Is that a monoatomic or polyatomic ion?
Poly.
How many elements make up the chloride ion? How many elements make up the chloride ion? One.
So
It's mono. It's monoatomic. So we said always go by your negative charge. Is more than 2. Because we could do, this one will be added on probably later. See, this is a polyatomic ion as well. It's the acetate ion. Well, look at how many elements these are. It has to be more than 1. Okay? All right. So, the reason we say that is you could be asking yourself, we already know what the charge of calcium is. Well, that's true. But we want you to remain consistent on how you figure these out. If you always start these the same way, you're always going to be correct. Well, I don't want to say always, but if you approach these the same way, chances are you're going to get them correct more often than not. And what we mean by that, the chloride ion has a charge of negative what? And then calcium has a charge of plus what? So these two don't add up to 0. Okay? You solved the case? What? Okay? So, now we're going to throw a breaking ball at you. Okay? All right? So, now, what's the symbol for tin? Okay? What's the formula for the sulfate ion? That's sulfide. What's the sulfate ion? SO4. You said S. Someone said just S. Okay? So the charge of the sulfate ion is... Now, before you say anything else, don't be one of these people. Why is that wrong?
That shows that you have 4 of the elements that charge.
Correct. Okay? So why do we have that Roman numeral?
Because it's positive 4 charge. So you have to get the ears.
Yeah, that's right. Find box number 50. What does it say inside box 50? So you don't know which one it is, but this is telling you that then. Okay? So now, what's not the least common divisor? We want the least common multiple. We want the least common multiple. You're giving me the least common divisor, which is 2. We want the least common multiple. 4. So remember, we did this in physical science. We said the answer that you get from this division tells you what to put down below. So 4 divided by 4 is what? I'm going to have to go. I sure hope that Ms. Doctor listens on this conversation. I say 4 divided by 4 and we say 0. Okay. Are you going back to saying 3,000 words again? Okay. So what's 4 divided by 4? 1. How many do we have right now? 1. So we don't need to do anything. We're going to get to your ears here shortly. Okay? So what's 4 now? Don't say -2 is the answer. This has nothing to do with the value. It's just the charge. Okay? So now, when you do this, why is that incorrect so far? Okay? So this tells you we want 2 sulfate ions.
Is this a polyatomic? Or is it monoatomic?
Which one?
It's a poly.
This is a polyatomic ion because there's more than one element that makes up the charge. Monoatomic ions are just like the halogens. They only have one element that makes up one charge. When you have more than one element that makes up a charge, that is a polyatomic ion.
So it's by how many elements are in there, not by
Correct.
charges.
Correct. Okay?
So this right here is a poly.
Yes.
And the first one was a mono.
All right. Now, the last thing, we're not going to do it today, but some people, it's easy to make mistakes. If we need the atomic mass on this, okay, we have 110, so then, so 118, how many sulfurs do we have? How many oxygens? 8. Okay?
Wait, is this like what we're all doing this whole chapter?
Because eventually what you're going to do, okay, this is what a general chemist may do, because when we get towards the end of this chapter, when it comes to molecular and empirical formulas, molar mass, percent compositions, all of those, this would be perhaps a classic problem is, for instance, how many grams of sulfur are in, we'll just say 300 grams of tin sulfate. I'm just abbreviating. This is what we're saying, this is what we're getting at. These problems are going to get a lot harder real quick. Okay, we're going to get back to doing dimensional analysis problems. So what you're doing is taking this number and calculating, well, out of all them 300 grams, how much of that is sulfur? And in order to do that, you have to add up these atomic masses, and we've done that before. 118, 32, and then I think that's 128. And it's easy to make mistakes at that point in time. So we'll pick up with this again tomorrow.